In this illustration, we intend to simulate the U-shaped damper under the cyclic loading in the Abaqus software. As it can be observed in the shape, left side of the damper is quite fixed, and a cyclic loading is applied to the right side of the damper, and actually the purpose of this problem is drawing the hysteresis diagram of the damper. In this picture, the hysteresis diagram obtained from the Abaqus software has been compared with the laboratory results. As you observe, the results obtained from the Abaqus software are close to those mentioned in the article. Actually, we intend to simulate this article in the Abaqus software. The article is entitled Evaluation of Structural Behavior of Hysteretic Steel Dampers Under Cyclic Loading. I will enter the Abaqus software for simulation. I will click on Create Part. I intend to create geometric shape of the damper. I will select the modeling space as 3D, deformable, then select Solid and Extrusion. Enter approximate size equal to 1000 and continue. There are 3 dampers in this article, and we will simulate the damper on the left in the Abaqus software. The proportions and size of which can be observed here. I will enter assembly module. Click on Create Instance. Enter damper into the assembly module. Then click on Radial Pattern. Select damper. Done. Select this line. Enter the angle of rotation equal to 360 degrees and OK. I will click on Translate Instance, select the lower damper, done. First select this point, then this one, and OK. I click on Translate Instance again, select the lower damper, done. Here I will move the lower damper as much as 30 millimeters downwards. Click on Create Boundary Condition. Select Initial Step, then select Displacement Rotation and continue. Here I will select these circles. In fact, these circles are the places on which the bolts will be fixed. The dampers will actually become fastened on the plate by bolts. Here I will close all the boundary conditions of displacement. As a matter of fact, as you observe in this picture, the dampers have been fastened on the plate by bolts. Here I will click on Seed Part and enter approximate global size equal to 3 millimeters. OK. I will click on Assign Mesh Control. Select Damper. Done. Here select Medial Axis and OK. Then click on Mesh Part and Yes. In the next step, we intend to draw the hysteresis diagram of the model. Actually, we intend to draw this diagram in the Abaqus software. I'll click on Create XY Data, select ODB Field Output, Continue. I will select Unique Nodal. First, select RF2, or the same reaction force directed at y-axis. Then select U2. I will select Set 2, that is the place of cyclic loading, and click on Save. I'll click on Create XY Data, select Operate on XY Data, Continue. Here, we should add up all reaction forces together. I will select Sum option, then click on Add to Expression. Click on Save As. Here, you observe the hysteresis diagram of the model. I will transfer the diagram to the Excel software. The first column is displacement, the unit of which is millimeter. The second column is force, the unit of which is Newton. Here, the diagram having been drawn with red color is the one having been obtained from the Abaqus software. As you observe, the results obtained from the Abaqus software are really close to the results mentioned in the article, indicating that the question has been simulated correctly in the Abaqus software. In this diagram, the horizontal axis is displacement and the vertical axis is force.